Hey guys, today we'll be doing LeetCode number 11, container with most water. This is a medium question, and the technique that we use for this is called the two pointers. I'll go over what two pointers are briefly. Two pointers, essentially, if you've seen 2sum2 input arrays sorted, or let's say any sorting algorithm, like they've given you a sorted array and you have to do something with it. Usually you can use two pointers on that. The thing with two pointers is you essentially just play with your left and your right pointer. They are allotted some, let's say if they're at 0 and they're at the very end of the array for right. So either one of those, they could be, usually we start with this. So left is at the very start, right is at the very end, and then you increment or decrement your left pointer and right pointer to get to some point. That's what the algorithm, the pattern is in a nutshell. And let's see how this would apply to container with most water. Now we'll do the same thing. Like I said, this is an example that I've just drawn on. Let's consider this one to be 1, 7. We'll say, let's redraw this. We'll say this is 6. Okay, so this is just like showing the example that LeetCode has given. Right, I'll make it easier. This is just a condensed version of that, and we'll say this is like 3. Okay, doesn't really matter. We don't really care about these two actually, like these two, but that's besides the point. Okay, so we'll consider our left pointer here, our right pointer here now. Okay, and when you look at this, think of a rectangle. Okay, essentially all we're doing is we have a rectangle and we're filling it up with water. Now when you have a rectangle, or let's say even if you had a barrel, okay, you had like a barrel, and if I said that the wood, okay, the wood that aligns with it, so let's say these two are full, but then there was like a small hole in the middle. Okay, there was like a small hole in the middle. When we put water into the barrel, like till what amount would it fill itself? Obviously up until the hole, right? Because any amount of water you put after that, it will just spill out. So it will just like spill out. Okay, think of it that way. And it's the same way here. If you have a rectangle and we have it capped at 1 over here, we have this at 0, this at 6, sorry. So if you have it like that, then the maximum amount of water that you could fill in this hypothetical rectangle would still just be like, it would be, the limiting factor would be this 1 over here, right? Because that's the maximum you can fill before it starts spilling out, correct? So we can establish the fact that when we consider the area of the rectangle, right, the thing that matters the most is the minimum of the two heights, correct? And we already have L, we already have R. Would it be safe to say that the base, like the base of the rectangle, or the length as some would say, right, that would just be R minus L, because that's the number of units that you just have to step over, right? So if let's say L was 0 and R was 5, then the base would be 5, right? And our height, as they say, would be the minimum of 1 or 6. So it would be 1. The maximum area that we could fill then, as the rectangle's formula is base times height, right? So it would just be 5. That would be our maximum area for this particular rectangle. Okay, now let's consider another one, right? We'll go from 7 to 6 now. So let's ignore this. We'll consider 7 to 6 now, and we have this rectangle over here. We'll apply the same algorithm. 7 and 6, the minimum would be 6, right? So our height would be capped at 6. Our base would now just be, we'll consider this to be 1 now. 1 minus 5, 1 minus 5 would be about 4, so 4 times 6, we would say 24. I've noticed that it would have been more appropriate to call this 4 actually. Let's just do that. Base would now be 4 and 3, so it would now be 18, right? And if we did the same process for every single other rectangle, you would notice that, well, because the minimum is so limiting, right? Like, even if you have, let's say, 99 on one side and you have 1 on the other, your area is capped to 1, right? So if you look at it visually, the two peaks that have the most height are essentially always going to be the ones that, not always, but the very best shot that you have is that those two are essentially the ones that you want to like store the maximum of, right? Because those will more than likely be the maximum. And we'll write this out in code now, right? We'll say LR0 len, right? And also there's actually another thing in this. If you are sitting on a, let's say, if you are sitting at the tallest rectangle, it would be dumb to move away from that rectangle, right? Essentially what I'm saying is, if we were sitting at 7, right, and we got the maximum right now from 7 and 6, right, it would be dumb to move away from 7 and move on to a lower one, because we would know that 7 was actually the best candidate for it, right? If, let's say, 7 moved to 99, okay, we'll say 99, and 7 moved to, we'll say 7 moved to 6, and this stayed at 99, and let's say 6 was now 99, it would be dumb to move from 7 to 6, because, well, 7 times 7 was the limiting factor in this case, right? So moving to 6 would just not make sense. It would be more appropriate to move the right one to a higher one, right? I mean, I'll show you what I mean. This might sound a bit complicated, but if you consider max area, and if you write val L is less than or equal to R, we can say the width, or the base in this case, we will say that's going to be L minus R minus L, sorry, because R is the one that starts ahead. And we will say height to be the minimum of the two that we are on. So height L and height R. So now we get the minimum height that we were in. So limiting factor, right? Area is just base times height. And maximum area would just store the current maximum as this. Now here comes the next part, okay? When do we know which one to increment, which one to decrement? Like I said, 2 pointers is basically a strategy to increment or decrement, right? Like I said, if the one that we are on right now is actually greater than, let's say, the one that we have at the very end, so left and right, then it would be dumb to move away from the left, right? Yeah, because obviously the right is the limiting factor in this case, so we want to move the right. Then we'll do that. Else we'll just move left plus equals to 1, because if in the other case it's less than or equal to, and if it is less than, then moving the right would be dumb, because right is the limiting, the left is the limiting, right? And it's just at the end, just return your maximum area. So it's essentially just that. I'll show it again just in case it was too fast, but yeah, it's just this. You have two pointers, you have a maximum, you get your base by r minus l, you see that the limiting factor is the height, calculate the area, store the maximum, and then the most important part is knowing when to move your pointers. If you're sitting at the best, then it's obviously better to move your other one, but if you're not sitting at the best, then you should move yourself. Good, okay? And you could essentially, this one you could solve it visually, right? Obviously I think everyone should be able to solve it visually. By looking at it, you can determine which one, right? And you notice that, okay, the two of the highest should ideally have the most. And in the first example, as they've shown, 8 8, the issue with 8 8 is that the width, so the r minus l, that one is smaller, we get a higher area from 7 and 6, sorry, from 8 and 6, 8 and 7, 7 being the minimum. Yep, there you go. So it's just that, and this is a smaller illustrative purposes bit diagram over here.